Hi there, my name is Will Coy. My name's actually Michael Scheidel. I live in Columbia, South Carolina, the capital of South Carolina, home of Fort Jackson Army Basic Training. I've started a new channel here called Mars, A New World. Basically, I'm going to be following the program, the missions currently to Mars. And right now, the genesis of the missions to start our manned missions to Mars around 2030 is the SLS program, which is the Space Launch System. The Space Launch System is currently in development, and they will be doing some actual testing tomorrow, July 2nd, on the abort capsule part of the Orion capsule, and so it'll be interesting to see how that mission, how that test will go tomorrow. I believe that's around 2 p.m. Eastern Time at Kennedy Space Center. I hope to maybe do a live stream or something with that, but we'll see. This is just starting here on this new channels, and there'll be a lot more that we'll be doing here as I try to evolve and build with the channel. So I hope you continue to follow with me. This is again, this is probably the first video that I'm going to upload, and I just want to introduce myself, and I'm going to read real quickly a fact sheet from NASA.gov of the Space Launch System. I think this is right now the core. This is the hardware, the rocket that's going to get us to Mars. And obviously, they're going to be doing some missions to the moon. I believe the first mission around 2020 next year will involve just basically sending the rocket out to the moon and deploying some satellites. Eventually, missions will be manned missions to the moon around 2022, 23, I believe. They will continue probably with some missions around to the moon, but then there'll be now this here I'm only kind of guessing, but obviously there has to be materials already sent sent to Mars, the habitat modules, tools, water, oxygen, a list of numerous things that need to be there once we do send our first men and women around 2030. So right now, we're just going to be following the SLS program in its evolution. But let me just read off the fact sheet. I just want to just provide you some information about the rocket and what NASA has provided us. And it begins here. It says Space Launch System, America's rocket for deep space exploration. NASA's Space Launch System, or SLS, is an advanced launch vehicle that provides the foundation for human exploration beyond Earth's orbit. With its unprecedented power and capabilities, SLS is the only rocket that can send Orion astronauts and large cargo to the moon on single mission. Offering more payload mass, volume, capability, and energy speed missions through space than any current launch vehicle, SLS is designed to be flexible and evolving and will open new possibilities for payloads, including robotics, scientific missions to places like Moon, to the Mars, Saturn, and Jupiter. The SLS team producing NASA's first deep space rocket built since Saturn V. Engineers are making progress towards delivering the first SLS rocket to NASA's Kennedy Space Center in Florida for its first launch. The power to explore beyond Earth's orbit. To fill America's future needs for deep space missions, SLS will evolve into increasingly more powerful configurations. SLS is designed for deep space missions and will send Orion or other cargo to the moon, which is nearly 1,000 times farther than where the space station resides in low Earth orbit. The rocket will provide the power to help Orion reach a speed of at least 24,500 miles per hour, need to break out of the low Earth orbit and travel to the moon. That is about 7,000 miles per hour faster than the space station travels around Earth. Every SLS configuration uses the core stage, With 4 RS-25 engines, the first SLS vehicle, called Block 1, can send more than 26 metric tons or 57,000 pounds to orbits beyond the moon. It will be powered by twin 5-segment solid rocket boosters and 4 RS-25 liquid propellant engines. After reaching space, the interim cryogenic propulsion stage (ICPS) sends Orion onto the moon. Next planned evolution of the SLS, the Block 1B crew vehicle, will use a new, more powerful exploration upper stage (EUS) to enable more ambitious missions. The Block 1B vehicle can, in single launch, carry the Orion crew vehicle along with exploration systems like the Deep Space Habitat Module, which obviously they're going to need to send those materials, and the Habitat Module, these huge cargo that's going to need to be sent to Mars in order, again, to facilitate the first manned mission. So it'll be interesting to see how these are sent there initially, and where they decide where the first manned mission will be at on Mars. Anyhow, we'll continue on here. The Block 1B crew vehicle can send approximately 37 tons, 81,000 pounds to deep space, including Orion and its crew, launching with cargo. Only SLS has a large volume payload, fairing to send larger exploration systems or science spacecraft on solar system exploration missions. The next SLS configuration, Block 2, will provide 11.9 million pounds of thrust and will be the workhorse vehicle for sending cargo to the Moon, Mars, and other deep space destinations. SLS Block 2 will be designed to lift more than 45 tons, roughly 99,000 pounds, to deep space. An evolving design provides the nation with a rocket able to pioneer new human spaceflight missions. Goes on to say Space Launch System Missions Exploration Mission EM1. This is about the missions, and again, it's going to continue to say EM-1 or 2, but that's Exploration Mission EM1. The first integrated flight of SLS and Orion uses Block 1 configuration, which stands 322 feet taller than the Statue of Liberty. It's a big rocket and weighs 5.75 million pounds. The SLS will produce 8.8 million pounds of maximum thrust, 15% more thrust than the Saturn V rocket. Now, if you ever watched the Saturn V during the Apollo missions, that was a beast. This is a monster. For EM1, Block 1 will launch an uncrewed Orion spacecraft to an orbit of 40,000 miles beyond the moon, or 280,000 miles from Earth. This mission will demonstrate the integrated system performance of SLS, Orion, and Exploration Ground Systems teams prior to a crewed flight to send Orion to lunar orbit. SLS will also carry 13 small satellites, each about the size of a shoebox, that will be deployed in deep space. And this is continuing about EM1. This is about the first mission. So we're talking about, I believe, next year, 2020, 2022, these initial flights, tests here, or missions to the moon. That's, again, EM1 Exploration Mission 1. Okay, I'll continue here. Building the rocket. NASA is building the rockets needed for the first and second missions to reduce cost and development time. NASA is using proven hardware from the Space Shuttle and other exploration programs while making use of cutting-edge tooling and manufacturing technology to build SLS. Some parts of the rocket are completely new. Other parts of the rocket have been upgraded with, hot there. Okay, where was that? To reduce costs and development time, NASA is using proven hardware from Space Shuttle and other exploration programs while making use of cutting-edge tooling and manufacturing technology to build SLS. Some parts of the rocket are completely new. Other parts of the rocket have been upgraded with modern features that meet the needs of challenging deep space missions, which require higher launch vehicle performance levels than available using other existing rockets. About the core stage. The Boeing company in Huntsville, Alabama, is building the SLS core stage, including the avionics that will control the vehicle during flight. Towering more than 200 feet with a diameter of 27.6 feet, the core stage will store 730,000 gallons of supercooled liquid hydrogen and liquid oxygen that will fuel the RS-25 engines, the four RS-25 engines. The core stage is being built at NASA's Michaud Assembly Facility in New Orleans using state-of-the-art manufacturing equipment, including friction steering welding tool that is largest of its kind in the world. All major structures are being outfitted for EM-1, and Boeing has started building structures for the EM-2, which is the Exploration Mission 2s, which are probably the manned missions and other materials, missions, hardware, cargo that need to be sent to Mars. For SLS Avionics computer software is being developed at NASA's Marshall Space Flight Center in Huntsville. Okay, some information here about the RS-25 engines, those 4 engines on the SLS. Propulsion for the SLS core stage will be provided by 4 RS-25 engines. Aerojet Rocketdyne of Sacramento, California is upgrading its inventory of 16 RS-25 shuttle engines to SLS performance requirements, including a new engine controller, nozzles installation, and required operation of 512,000 pounds of thrust. During the flight, the 4 engines provide around 2 million pounds of thrust. The engines for the EM-1, which is the Exploration Mission 1's first missions, are built, tested, and ready for attachment to the core stage. After the engines are installed and the core stage is fully assembled, NASA's Pegasus barge will transport the entire stage to Stennis Space Center near Bay St. Louis, Mississippi for green run testing. Then Pegasus will take the core stage to Kennedy Space Center in Florida, where it will be prepared for launch. Aerojet Rocketdyne has finished testing new controllers for EM-2 and has started development testing of new advanced components to make the engines more affordable for the future missions. Okay, a little bit here about the boosters, the 2 solid boosters. 2 shuttle-derived solid rocket boosters will be used for the initial flights of SLS to provide the additional power needed for the rocket. The prime contractor for the boosters is Northrop Grumman of Redondo Beach, California, and has modified the original shuttle's configuration of 4 propellant segments to a 5-segment version. The design includes new avionics, propellant design, and case insulation, and eliminates the recovery parachutes. At the Utah facility, Northrop Grumman has cast all booster segments needed for the EM-1 Mission 1s and started casting booster segments for the EM-2 missions. At Kennedy, engineers are refurbishing and upgrading space shuttle booster components to meet the SLS requirements. Trains will carry these booster segments from Utah to Kennedy Space Center, where they will be stacked with other booster components. The booster avionics systems are being tested at Kennedy and Marshall. A little bit about the payload adapter here. Spacecraft and payload adapter fairings, excuse me, and in space stage. The Orion stage adapter will connect Orion to the ICPS on the SLS Block 1 vehicle and is the place where the small satellites will ride in space. The Orion stage adapter has been delivered to Kennedy for the first launch. Teledyne Brown Engineering of Huntsville, Alabama, has built the launch vehicle stage adapter that will connect to SLS core stage to the upper part of the rocket. The initial capabilities to propel Orion out of Earth's orbit for Block 1 will come from the ICPS based on the Delta cryogenic second stage used successfully at United Launch Alliance's Delta IV family of rockets. It uses one RL-10 engine made of Aerojet Rocketdyne. The engine is powered by liquid hydrogen and liquid oxygen and generates 24,750 pounds of thrust. This stage has been delivered to Kennedy and is ready for integration before launch. Okay, and that was about the Orion, about the initial where these initial satellites and all will be housed on top of the rocket on the SLS. Okay, a little bit just about the SLS team here. It just says here SLS is America's rocket with more than 1,000 companies from across the U.S. and every NASA center supporting the development of the world's most powerful rocket. The SLS program at Marshall works closely with Orion program managed by NASA's Johnson Space Center in Houston and the Exploration Ground Systems at Kennedy. And there is the end of basically the fact sheet about the Space Launch System. The Space Launch System, the SLS, here is the genesis. This is the core hardware of rocket that's going to get men and materials off of Earth into, right now, towards the moon. But obviously, the goal here is Mars, which is looking around 2030. Hopefully, we'll see some good things out of the SLS. Hopefully, everything will go good, and the teams will make their mark on the testing and the missions. So we'll just have to see what happens, and we'll find. I'm going to use this channel to follow along on a lot of these tests and the missions themselves. Obviously, I would like to do some live streams during the missions, and even during some of these testings. I might try to do a live stream tomorrow on this test here about the abort part of the capsule, and probably find out some more information about that. I was just reading just a little bit about it before I started to begin this video. I just want to start off with this. It's like I said, this is the first video for this channel, Mars. Mars, the new. I'm sorry, I apologize. I didn't even remember my own channel here. Anyhow, it's kind of going off of things here. But I just want you to come onto the channel, subscribe, hit the bell there twice. That will alert you, notifications when I do come on live. If you want to follow along, if you find this very interesting about the Mars program, I think it's this is really in the works. This is the next step. This is the next journey. This is discovery now. This is where we're going. This is the future. And right now, I grew up watching basically the shuttle program ever since 1979, the first shuttle missions, and watched most of all the launches. And right now we're just not much going on in the NASA program, since Russia has pretty much taken over all of the manned launches and cargo missions. Well, not all of them, but SpaceX has been doing some launches, and that's been pretty interesting. But this here is, I think, the most interesting thing right now as far as space exploration, and that is the SLS and watching it evolve. And so I hope you do follow along, and we'll probably grow and see more things here. If you'd like to donate or anything, that will be used here for the channel. It's most appreciated. I'm learning a little bit about that monetization. So anyhow, right now, I'd just love to see you just subscribe, and if you like, please. I'm learning a lot myself about the missions and the hardware. If I say something that maybe you need to correct, or maybe please email me at willcoy803@yahoo.com, or maybe on these chats you can I'll be watching that live too, and perhaps you'd like to share something that would be helpful, or at least need to share with people watching. So with that, I'm going to end. I hope there's a little bit of information, at least about the SLS. That is I believe the beginning. What we need to start. We should start the channel and about information about the rocket, and it'll be very interesting once when they launch that sucker, because it's going to be a pretty powerful rocket when it gets off the platform. Again, like I said, I'm very fascinated about the space program. Always have been. I was born in Cocoa Beach in 1968. I'm 51 years old, and my parents worked at the Cape. My father, my grandfather, actually was in the Corps of Engineers, and he helped build some of the platforms for Apollo and Gemini. But with that, again, I go by the name of Wilcoy, Wilcoy. I'll end this video right there, and hopefully maybe we'll see you tomorrow. You have a good day. Bye.